one more reaction was there of carbene addition is that alkene when we are having alkane with CH2I2 and copper zinc, we are reacting it with copper zinc, so we are getting what? Okay, so again this carbene is attacking over here, we can see. Is that clear?
Yes, ma'am, clear, ma'am.
Next is addition of HNO3. In this we are having again alkene, we are adding HNO3 to be like this. So one is OH and another one is NO2. Out of these, one side OH will attack, another side NO2 will attack. NO2 will attack. Got it or no?
Ma'am, on any side they can attack.
Okay. Any side in the sense OH and NO2. OH negative, NO2 positive. Right? So it is nitro alcohol, which is forming over here. Next is very important reaction, addition of Tilden's reagent, NOCl. That is Tilden's reagent. So we are having with us this alkene. That you can write it as R, so as to make it unsymmetric. When you attack Tilden's reagent is what? NOCl. So NO positive, Cl negative, it will produce. So according to Markovnikov, we have to attack it. Tell me what will happen when we attack it according to Markovnikov.
Cl will attack CH2 and NO will attack.
Will attack this switch.
Yes, ma'am.
This is Markovnikov addition. Similarly,
Now, why it will follow on Markovnikov? Which
in the again the similar manner double bond migration will happen. Markovnikov rule is by, because double bond want to move over here so that the formed carbocation is stable with 2 degree in nature. So this carbon got a negative and this carbon got a positive charge. So this negative charge carbon will obviously attack over to positive itself, right?
Yes, ma'am.
H2SO4. Again Markovnikov rule. It's over here, add H positive over here, and over here OSO3H. Okay. Getting it?
Yes, ma'am. Getting.
One more addition like this. You're adding over here H positive ROH alcohol. So when we break this bond, hydrogen over here, OR over here. Negative part always over the carbon having less number of hydrogens, OR over here, and CH3. Got it? Similarly, if we attack H positive acid in the presence of carboxylic acid, RCOOH, we will get what? R, CH, CH2, H will attack over here, and OCOR will attack over here. Got it now? Mention.
Yes, ma'am, got it.
Thinking. I am thinking interhalogen compound means ICL. So it is interhalogen compound. So in this ICL, tell me which is positive and which one is negative.
Ma'am, Cl will go to that RCH, that carbon, and I minus will attack this difference.
Not I positive. Correct, no?
Yes, ma'am, I positive.
Next is solution of alkanes. Now alkanes is highly branched. Then it will do that. So this is a alkane which is highly branched. This is highly branched alkane in the presence of H2SO4 or HF. Temperature is 0 degrees Celsius. So at that time, what happened? Bond again will cleave over here like this. Right? When this bond migrate over here, up now tell me that this carbon and hydrogen bond cleavage happen. So obviously this carbon is occupied by 3 alkyl groups. So hydrogen will take that electron with it, right? So this carbon got a positive, that is stabilized by 3 methyl groups, right, Imansh?
And because of the 3 methyl groups, H minus and C plus will be formed, and this plus is stabilized by the 3 groups we are saying. So due to this reason, now carbon will attack over this carbon. So we are getting CH3, C, CH3, CH2 will attack over the carbon over here, containing 3 CH3 groups. And over here is hydrogen. Is it clear? Yes, ma'am, clear.
Okay. Now, dimerization reaction. Very easy reaction. Dimerization means dimer is forming over here. Means alkylation of alkene. Means in alkene itself we are adding another alkene. Let's see. Let's say we are having CH3. C, CH3, double bond, CH2, H2SO4, and 80 degrees Celsius temperature we are providing over here. What will happen? Another alkene. ये इधर, right? This bond will migrate over here. This bond will migrate over here. Are you getting it, Himansh? This carbon will attack over this carbon because this will get a negative charge. That negative will attack with this positive charge carbon. So we are getting CH3, C, CH3. This CH2 attacks to this carbon containing 3 CH3, 2 CH3, and 1 CH2 with a negative charge. That negative will be compensated by H positive, so it will be H, and this positive which is generated over here. Here is a positive, okay. So it's a positive over here, right? So it will be eliminated by this group, or it's this one, right? And then any of the beta carbon will participate in that elimination, so it can form two products. Or it can form CH3, double bond, CH2, CH, C, and 3-methyl group. Is it clear to you or no?
Yes, ma'am, clear, ma'am.
And if to these, if we are adding H2 nickel, H nickel is at least H2 is adding to the double bond and making it as like this. Okay, this is the final product we are getting. Any doubt, Imansh?
No doubt.
One more I'm going to do. You have to automatically think about a reaction like this is the beauty. Butene undergo dimerization. How? Hne, sunlight, high energy radiation. So this bond will move over here and this bond will move over here. So there is the creation of a 4-membered ring like this. This is a 4-membered ring. Cyclobutane. Okay. If we are having, let's say, normally this is given to you H positive. So what you will do now, because you know that we are having cycloalkene, so bond will shift over here, let's say. When this bond shift over here, it will attack over to this carbon because this bond shift over here. Are you getting it? So we are having this type of structure. Over to this carbon is a positive charge. This carbon got a negative charge. That negative is attacked over there on this another carbon. This carbon got a attachment by the ring, and this carbon, neighboring carbon, got a negative charge. Correct, na, Himansh?
I mean, out of these two molecules, opposite the bond shift and the bond between them will be formed. It's positive and negative.
On the dash where that correctly I'm writing in place of that negative H positive. Here, H positive. But as I told you, whenever we are having a carbocation, there is a possibility of rearrangement. So this is 2 degree carbocation. If I do that 1,2 hydride shift, so at that time we will get a, see, these type of questions are very common in advance, telling you. You have to use your own brain while these type of questions. It's not like you have seen the reaction, so you are doing that question. No. It's like you can be framed with numerous type of example. They can give you the reagent. All you need to know is the function of that reagent, that what the reagent is doing over that. Okay, so you just have to create that reaction by your own itself. But getting it? You need.
Yes, ma'am.
Now this is carbocation and this is stable. That is why it is forming. Now we are removing the hydrogen from that side where we are getting a stable alkene, more substituted alkene. That is why this type of alkene is shown over here. Got it? In your Narayana's book, direct product is given. No mechanism, they are showing you that how it is happening. And this was, I guess, a PYQ, and I don't know, but I have seen this question in your past year exam, don't know in mains or in advanced. There was some question related to this concept. Very much pretty similar to this concept.
And that bond, hydrogen bond breaks and a double bond is forming between them.
Any problem in that, Himansh?
From that hydrogen bond breaks and a double bond is forming between them, ma'am.
Oh, this is that alkene formation, in preparation of alkenes, dehydration reaction, remember?
Yes, ma'am.
And as we did have formed that double bond only, like this only, like in the first step H positive is added, in the last step H positive is removed. Okay? I'm again telling you, Imanj, just revising the reaction, don't miss any of the reaction that we discussed there in the class. Just keep revising them on a daily basis. So these questions are very simple. If you thoroughly revise them, you will get it to be very easy. Okay? Himansh?
Yes, ma'am.
Moving on to the next reaction, that is the reduction reaction. The reduction reaction is catalytic reduction. Catalytic reduction means we are using catalyst, and it is very important, very widely used. So we are having alkene. We are applying hydrogen. Reduction means hydrogen we are supplying. Now the catalyst is either platinum or palladium or nickel. Okay? Or sometimes PtO2 given that. So it will convert that to R, CH2, CH2, CH3. Okay?
Yes, ma'am.
So nickel is written as rananic. Nickel. This is what we are doing over here. Just a double bond breakage, H over here, H over here. Actually what is happening now, that hydrogen is like this. So hydrogen and this alkene move over the surface of metal. When it move over the surface of metal, It is creating a type of bond in between them, breaking the bond of each other, breaking the bond of each other. So this is how the reaction is happening. Got it?
Yes, ma'am, got it.
Whatever the question given to you, you have to think about it.
Due to presence of this platinum, palladium, and due to the presence of this platinum, palladium, this structure is formed now, and the hydrogen is bond breaking and which carbons bond forming.
Because nickel, in case of nickel, we require high temperature. But palladium and platinum, when we use, it can occur at room temperature. Maybe you are having a terminal bond of alkene. This is a terminal bond of alkene. So it is by Birch reduction. It is terminalized. Remember Birch reduction.
Yes, ma'am.
Remember?
Yes, ma'am, got it.
We are using in Birch reduction. We did discuss that complete topic, right? RCH2CH3. We are getting. Similarly, out the slide. From NCERT, if you take a look at the chapters of this organic, it is very simple then. They are just writing the reactions and not even writing that whole reaction that is asked there in your advance and all means type of questions, no?
Yes, ma'am.
20 books of organic is too easy. Then cyclohexenes. Is used. How it basically behaves over here. See, very interesting. Hydrogens over here, na? Itself eliminate out and create a benzene. And that hydrogen they supply to this alkene and create the alkene. Got it?
Automatically in presence of CH to CH it will convert it. No?
Sorry?
Automatically in the presence of CH2 it will get converted. No? Yes.
After that, let's say this is the structure given to you. You're adding hydrogen. So always remember that it is syn addition. Means on a same plane it adds. So it's a syn addition. Means we are adding, let's say methyl, hydrogen, okay? Other way of using the very important, very widely used reducing agent is Wilkinson catalyst. Wilkinson catalyst. Now what is Wilkinson catalyst? It is a complex of rhodium, PPH3, thrice, NaBH4, In the presence of AlCl3, diglide. NaBH4, in the presence of PtCl. Got it?
Yes, ma'am, got it, ma'am.
Then during reduction with the diamide. Second type of reduction is reduction with diamide. So N2H4 is diamide. N2H. This is hydrogen. N2H. Seems to be like this. When it reacts with alkene, any of the alkene, so like, oh, 1 second. This is the structure of it. So just look into the bonds, how I'm creating the bond. Here a bond is forming. When nitrogen forms a new bond, it will transfer it the old bond. In carbon double bond carbon is like this. So kind of cyclic transition state we can show. Okay, na? Finally, nitrogen. No, once again. Nitrogen creates a triple bond with nitrogen N2 plus this carbon double bond carbon gets attached with this hydrogens. Is it clear to you or no?
Yes, ma'am, clear, ma'am.
Cyclic transition state. Also, one more question, stability. If I ask you about, there are two types of structures. Can you tell me that out of these two, which one is more stable and which one is less?
And both will be equally stable, you can say.
is the difference that you can spot in your book.
Only that there's change in the double bond position.
But that doesn't change the double bond position for particular metal right?
Ma'am, what ma'am? Change in double bond.
Okay. This one is trans and this one is cis.
Yes ma'am.
Correct, no?
Yes ma'am. Yes ma'am.
And out of trans and cis, which one is not stable?
Cis trans will. Cis will. Ma'am, but ma'am,
Sorry, trans.
trans will yes ma'am. The trans will be more stable, no ma'am.
Mm, trans will be more stable, but no, cis is more stable over here. The reason behind it is this is the hydrogen which is present over here. This hydrogen will try to repel the hydrogen that is present over here. Getting it? But here the hydrogen is quite dispersed like this.
But in the case of cis, two repulsions will be, no ma'am.
They are like out of the plane, coming out of the plane. But it is just beneath it. This hydrogen will overall interact with these. Getting it?
Yes ma'am, getting.
So after reduction, let's move on to another point, that is oxidation. So very important. First one is hydroxylation. With Bayer's rate. Bayer's reagent is what? Cold, alkaline, KMNO. It's having pink color. So when we are having any alkene, and if we add Bayer's reagent to it, it will be converting to 1,2-diol. Now the point is why? This is an alkene. And Bayer's reagent is MnO4. KMnO4 no? KMnO4 means MnO4 2 minus. MnO4 minus. So this is forming a bond over here. This is forming a bond in between carbon oxygen. Here it is a bond in between oxygen and carbon. Got it?
I mean, C plus and C minus are forming, and
Carbon is forming a bond with oxygen. The oxygen, MnO, and this O. It is like oxygen multiplied with that. Okay? Oxygen gives electron to Mn donate the electron to oxygen, oxygen donated to carbon, carbon double bond creates over here. Is that clear or no? You're confused now, I guess. See this, I will open that negative only, then only I will explain it to you. Let's say this oxygen is having KMnO4 is like MnO4 negative. Okay, oxygen you can see that it is having electrons. So it is having electron, so we just consider that double bond will break in a manner that oxygen is giving that electron to this carbon. Okay, there is a bond between oxygen and carbon. When this carbon take an electron, it will spread this electron over here, and when this carbon give that electron to oxygen, oxygen donated back to manganese. Getting it or no?
Miss,
This is what actually formed. Okay.
means K in KMF4 K goes on O minus is forming and the C plus and O minus were forming bonds we are saying, no?
Any problem?
Got it, ma'am, no problem.
So here is a bond elimination we can say happening, and now finally when OH negative attacks over here, it will break the bond, and ultimately that will be converting to OH, OH. And MnO. Okay, Manch.
Yes, ma'am. Okay, ma'am.
This is a thin addition. Sin addition. Now have a look. See, I will explain your rule. There is a trick, and it's very important. Car down. C means cis, anti, racemic, trans, anti, east. Getting it? Like if we are having cis alkene and any anti addition happens, anti addition means group which add the groups in the opposite side. Anti manner attack it happens. Like remember bromination we did? That was anti. Remember or no? Imansh.
Yes, ma'am. Got remember.
And trans anti needs it. Accordingly, you can make that opposite. Like for this, if sin addition happen, I will explain how we have to apply this thing. Meso product is forming, and to trans sin addition, it is forming racemic opposite. Let's discuss how it is happening. Let's say I'm having over here alkene. Tell me whether it is cis or trans. Much.
I'm just now.
Yes, why are you confused with it?
Ma'am, hello, ma'am. Ma'am,
Why
cis
are you-
iso. Ma'am, cis iso,
This
ma'am. Ma'am, your voice is breaking. Ma'am, that's ma'am.
Okay. Is it breaking now or is it fine?
Ma'am, whenever I try to talk, then it's breaking. Ma'am, that.
Okay. This is because from your end, some other background, we can say noise is coming. When you are turning on your mic, there is some background noise is coming, and I'm not using my earphones right now. So that is why I feel like your that background noise from my mic is, we can say, coming back to you.
Yes, ma'am.
So this is cis alkaline cold KMNO4. Right. Now, as we know that this is Bayer's reagent, and Bayer's reagent to thin addition. So cis sin. Remember? Cis
Sin.
sin.
Meso.
Meso what you have. Now how to create a meso? Let's see. This carbon carbon double bond. This contains CH3. CH3. Meso is like, this is a meso compound or not? Tell me. Remember meso or not?
Yes, ma'am. Meso
Meso
compound.
is a plane of symmetry, right?
Yes, ma'am.
That is called meso compound. And if it is trans, let's say, then if you do the same thing. So now for trans, see, trans doing chain elimination, race-me product is formed, right? So race-me product is like, how to form that race-me product? See. So this is the race-me product. Okay, this is equal quantity to D of N, that is race-me. Is it clear, Ansh?
Yes, ma'am. Clear, ma'am.
So this is a very short trick which will be used wherever it is like we're having cis or trans, whatever the condition is, alkene, and we have to add it in empty manner. We will get race-me for meso according to cis or trans, and if we have to attack it in thin manner, we will get meso race. Got it, Ivansh?
Yes, ma'am. Got it, ma'am.
Then also in Bayer's reagent, we can say this is used for test of unsaturation because the pink color of Bayer's reagent will disappear. So it is a test of unsaturation. Okay. Just like we did it for bromine water test in the previous class. Remember?
Yes, ma'am. Bromine.
Same goes with OSO4, osmium tetroxide. Means in addition. If we are adding OSO4, we are getting again that spin product. So how OSO4 is happening, how it is reacting, let's see. So over here, Bond is created like this. This is making a bond like this, and this is making a bond like this. Making a bond with oxygen, single bond osmium, O, and we add water to it. We'll ultimately break it down, and we are getting, if it is cis alkene, accordingly we will get. If it is cis alkene, we'll get whatever thing we are. Okay. Mensch.
Yes, ma'am. Okay, ma'am.
Then is anti dihydroxylation. Now we are adding it in anti-manner. Anti-manner. So alkene when attacked with peroxy acids. Then acidic or basic hydrolysis. Okay, so it will attack diols in this manner. So let's discuss about it. So we are having an alkene. For acid is like RCOOH is there, na? But here it is RCOOH. One more peroxy acid like this. So the main ultimate goal of this peroxy acid is to supply an oxygen, which will be adding to a ring like this. Okay, it is epoxide ring which is forming over here. This epoxide ring is obviously in one plane only, right or no, Himansh?
Yes, ma'am.
Now if H2O wants to attack, obviously oxygen got a positive charge or no? Oxygen got a positive charge, so it ultimately try to break the charge by taking the electron, break the bond. Ultimately the carbon got a carbon OH, and this is OH. They are opposite. This is anti-addition. This is known as anti-addition. Okay, so if we are having, let's say, this structure, and if we are having peroxy acids, either on wet dash or on dash dash. Is it clear or no? Match?
Yes, ma'am. Clear, ma'am.
Any doubts so far?
Ma'am, no doubt, ma'am.
We can now move on to another type of reaction, which is ozonolysis. Ozonolysis is very important, very important. It is of two types, oxidative and reductive. Let's discuss the two. We are having alkene. We are adding ozone to it. When we add ozone to it, it will produce this ozonoid. It will produce ozonoid. This is ozonide. This ozonide will ultimately, see, many more things are given over there in the book, but you don't need to go into that much depth. Like this bond will migrate over here. So this oxygen will leave out. Getting it now? How I'm telling to you?
Yes, ma'am, getting.
So this oxygen will create a bond over here. And ultimately this oxygen leaves out. So in short, what you need to do in short, just simply remember this thing. Level 1 oxygen, level 1 oxygen. Very short simple trick is like, don't go into the, we can say, much more detail into this. Just break this double bond, supply oxygen over here. That's it. Getting it?
Yes, ma'am, getting.
So this is in the presence of zinc and water we are. Any doubt, Iman, so far?
No, not this. I mean, the first step, how this structure is formed, ozonide structure.
How is this forming?
Yes, ma'am, it's ozonide.
Okay. That's an alkene. Ozone is like this. Correct? So we have to go into the mechanism first of all. This is a negative charge will attack over here. This will attack over here. And this will be taking the electron back. So carbon-carbon single bond, oxygen, 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 and a bond. Then what will happen? This carbon-carbon bond, it will transfer over here. When a new bond oxygen is creating, it is breaking the previous bond. Like this. Then carbon, double bond to oxygen, and this carbon got a positive charge, bond, oxygen, oxygen, and one more oxygen, but this oxygen is having a negative charge. Okay. Now what again happens is, see, this carbon is having positive no? Second. So oxygen will take an electron like this. Will take an electron like this. So this negative, this positive will create a bond, and this positive and this negative will create a bond. You getting it? Or no, Himansh?
Yes, ma'am.
Carbon, carbon. So this carbon, oxygen, oxygen, carbon. So oxygen, oxygen, carbon, and this carbon, oxygen, carbon, carbon, oxygen, carbon. This is what I have drawn over here, ozonide. Okay, so this is the Zwitter ionic intermediate. Zwitter ionic intermediate, it is forming because it contains both the positive as well as negative charge, and this is ozonide. that is unstable because it contains oxygen-oxygen single bond. Okay, so ultimately it will break. Don't consider this thing. Ultimately just break it out like this. Break it out because oxygen-oxygen bond is highly unstable. Just break this bond such that it eliminates like this. So carbon-oxygen double bond, carbon-oxygen double bond. So we are getting carbon double bond oxygen, oxygen double bond carbon. Got it? Kind of.
Yes, ma'am, got it. Ma'am.
So what is the functional thing that we are using this for? Zinc, because this oxygen which is free oxygen which is removing out this oxygen will react with H2 and form H2O2. That H2O2, the oxygen will combine with H2O and form ZnO, H2O. This is a very good oxidizing agent. So it will basically convert that aldehyde which is converted to carboxylic acid. Is it clear or no?
Yes, ma'am, clear, ma'am.
That is the reason it will come to convert it to carboxylic acid, which is formed by the para. So as to not do the process, zinc is to react with H2O to convert it back to zinc oxide. Yes. So prevent further oxidation. All right.
Yes, ma'am.
That is why we are classifying into two types: oxidative and reductive. The step is remaining the same, but if we are having let's say not availability of zinc or any other reagent is given to you, like if we want to use zinc acid or H2 rennet nickel or EPH3, so they will produce aldehyde and ketone. Aldehyde and ketone depending upon what type of alkene we are having. But if we are having H2O2 oxidizing agent, Ag2O, very important for acid, any of the thing given to you, it will form carboxylic acid fine as well, not aldehyde. Carboxylic acid will ultimately, like CHO we create that CHO, if we do the reaction, if it is like H, so we are getting CHO. So CHO, what we are getting, if let's say aldehyde, so aldehyde will automatically be converting to carboxylic acid. Ketone will not be affected by it. It will be ketone only. Ketone will not be affected. But if let's say LiAlH4 given to you and NaBH4, they are strong reducing it. They are reducing it. So if they are reducing agent, they will reduce aldehyde and ketone and they will convert alcohols. Got it or no?
Yes, ma'am, got it, ma'am.
So depending upon what other thing is given to you, you will have to do the reaction. Let's practice certain questions related to this concept itself. Let's say we are having this type of structure and you have to do ozonolysis in the presence of zinc H2O given to you. Okay, so what you will do now, just break this bond. Very short time. Okay, just break this bond like this, completely break this bond and supply oxygen and oxygen. And this. So that is the final structure you will get. Getting it or no? Manch,
Yes, man, getting.
if let's say I have changed the question to be like this. What's it? So they ask you that how many different type of drugs you are getting. So again you are breaking a double bond, oxygen, oxygen. You are breaking a double bond, oxygen, oxygen. So you are getting these fragments. Just apply double bond O, double bond O, double bond O, double bond O. Hydrogen over here, hydrogen over here. Any route. Manch,
No doubt, man.
let's say. So can you tell me that what are the previous products that you will form? If I give you H4, let's see. Man, what happened?
I mean, say the ring will be breaking into two parts. We can.
Can you send me the picture of your drugs, spine drugs?
Yes, man.
And this is very important topic. What is happening, Iman? Why are you taking so much time?
I'm sharing, man.
you don't know, you can ask me. Even lunch?
Ma'am, it's three products will be formed, we can say, but three bonds will break and
Huh?
ma'am, we have
Three
three.
products? You didn't send me that picture.
I'm sharing on the picture. I have one.
Hmm?
I'm sharing the picture, ma'am.
Get it.
Ma'am,
Okay. One cleavage over here happened.
just my
Another
second
cleavage
cleavage.
over here, another over here. So you are getting one fraction to be like this.
Yes, ma'am. 1 second.
Second is also like this. And the third one is those two carbons, CHOCH. This is your final answer, Imanj.
But third cleavage will be also in the same manner, ma'am, because
Oxygen, oxygen. So these two carbon will get only the oxygens. Now these are two aldehydes which is forming, and even H2O2 is given to you. So this is COOH. We are forming on the aldehyde COOH, COOH, and over here as well COOH. Getting it? What happened, Imanj? First of all, tell me.
no, but here carbon, this oxygen will also go to the
Hmm.
third cleavage also, ma'am. It can.
Which cleavage?
Ma'am, that third one, ma'am, you can say. Instead of
If it is first, if it is second, it is third.
yes, ma'am, the third
So
carbon.
third cleavage. Huh?
Yes, ma'am.
So oxygen is given to these and this carbons. This carbon, this carbon. What happened? I guess I need to repeat it once again.
Yes, ma'am. Can you repeat it?
Sure. What I did so far is now, Himansh, just to think about, we have just completely broken the bond. Completely broken the bond. So we'll get one, this thing, right? And correct or no? Himansh, tell me.
Yes,
These
ma'am.
three patterns clearly. Now you just have to look into the carbon which undergo the cleavage and you have to supply oxygen to them. So this carbon over here, this carbon over here, this carbon and this carbon, these two carbons. So here, this is a ketone, so it will be like this only. It's on the ending. So ending with aldehyde. Aldehyde will be converted to alcohol acid only. As I told you, H2O2 is there. So H2O2 is converting aldehyde to acid. Got it, Imansh?
Yes, ma'am. Got it.
This is internal. So this internal will be ketone always. This is ending, end part, end carbon. So it will be acid. These two are terminals. So it will also be acid like this. Alright.
Yes, ma'am. Got it.
I'll give you one more question, okay? Just try it now.
No, 1 minute, man.
What happened, Imaj? Why are you taking so much time?
I mean,
Tell me.
3 CHO. Man, I said 3 CHO bonds will be formed. We can say.
3 CHO CHO.
Yes, ma'am.
No. Imaj, what is going on? Like, why are you not able to do that? See, one bond breakage over here, second bond breakage over here, third bond breakage over here. Correct? And make the fragments like this. Correct or no? Tell me.
Yes, ma'am. First one. Right.
This one, and the third one. Now these are the endings, the carbons which undergo that cleavage, right? So you just have to supply double bond O, 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 double bond O. Since these are terminal carbons, so these are aldehydes. Terminal are aldehyde. That's it. Completed.
And 3 aldehyde groups form CHO groups.
Okay, you are telling me that three aldehyde groups about the aldehyde groups.
Yes, ma'am.
But although they are, I thought that CHO is like all you are telling me. I thought this. But aldehyde 1, 2, 3, and 4 aldehyde groups are creating the aryl mix. Nanj,
Yes, ma'am.
what happened?
I got it, ma'am.
So if they can ask you the question like, if they ask you the question like, this is, I guess, no, it's xylene, na? Orthoxylene. So this is how they give you the question. What happened when orthoxylene is undergoing ozonolysis? So this is one setup, but once that benzene can be either arranged to be like this as well, isn't it? How many products? 3 over here. And what are the products you will form by this? Will you try? Tell me.
Yes, ma'am. I will try, ma'am.
Just look into the structure and just remove that bond. Whatever bond is breaking, and just completely remove that bond. Into the carbon, just supply oxygens.
Ma'am, share the picture, ma'am.
Okay. No, Himanshu, all of them are high. Can all of them be? No. How you found that? What about these CH3 and CH3? They are nowhere you can see the CH3 only. You have drawn it for simple benzene, you know.
Yes.
What about these groups?
Ma'am, so then hydrogens.
Uh-huh.
I mean, in the first place, in place of hydrogens, that groups are CH3
That
mechanism.
in the first one?
Ma'am, in place of hydrogens,
Uh-huh.
CH3
Yeah.
groups, we should place one.
Correct. So one bond cleavage over here,
One
one
bond
over here,
and
and one
third
over
bond.
here. Only the three products that you have drawn, all of them are same only, and that is these two carbons, which is CHO and CH, CHO, CH. This no, Marsh. See here, second product which you will get is like this. These two carbons, like these two carbons, connected with CH3, CH3. CH3, CH3. So it's complete ketone that is forming over here like this. And the third one is also CH2. CH2. Got it? Himansh?
Ma'am, I also drawn the same number CH3 double ketone, and
Ah,
instead of hydrogens, if it place CH3, it will be.
correct. You have to create it like that. Got it? Or no?
Yes, ma'am, got it, ma'am.
Now I guess that ozonolysis concept is clear to you, isn't it?
Yes, ma'am, it's clear, ma'am.
But the question is like, there is a reverse ozonolysis as well. This is one. Reverse ozonolysis.
Yes.
Reverse ozonolysis. Reverse ozonolysis. So in reverse ozonolysis, we just have to reverse the process. Okay, so let's say this is the compound given to CH3, CO, CH2, 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 CH2. Okay, Himansh. Now they are asking that it undergoes ozonolysis. So you have to detect the reactant now. Are you getting it? So how to detect it? This is also having a short trick. Just remove this oxygen out and make a double bond in between them. 1, 2, 3, 4, 5, 6. Make a 6 number ring. 1, 2, 3, 4, 5, and 6. Create a double bond in between first and sixth carbon like this. First carbon contains CH3, put a CH3 over here. So this is your structure. Got it or no? Reverse ozonolysis means you have to take the reactant from the product. Got it? Himansh.
Ma'am, what, ma'am, we should do reverse of the ozonolysis, we are saying, ma'am.
Reverse of like product given to you, and you have to given about reactant.
Yes, ma'am.
Okay, is it clear or no?
Yes, ma'am, clear, ma'am. Got it.
So let's say what will you do? What will be the product you are forming? Again, ozonolysis. You have to reverse. So just eliminate oxygen. Also remember 1, 2, 3, 4. No. This will not be possible because you are getting a 4 member ring now. Eventually. 5 member or 6 member ring are fine. So we can create a 5 or 6 member ring. So just remove oxygens. With a 1, 2, 3, 4, 5. 5 carbon ring you have to form like this. 1, 2, 3, 4 and 5. First carbon contains CH. First carbon contains C, CH3, CH3. In between first and fifth carbon there is a double bond. Second carbon contains CH3 and fifth carbon contains CH3. Getting it or no how I drawn the structure?
Yes,
Lunch?
yes, ma'am, getting. At that,
Any problem? Huh?
we are making that oxygen and making bonds at that position. So you're saying.
So we are removing that double bond oxygen, no? So the both the carbon will together create a double bond in between that. So huge questions, huge. I must say, in advance there are huge questions related to this reverse ozone concept, where they provide you the product and you have yourself to answer the reaction. Got it or no?
Yes, ma'am, got it, ma'am.
And this like complete backfoot you have to go, right? So try to practice more and more questions related to this concept. Okay. Next coming class we'll discuss about reaction with KMNO. You must just tell me one thing that you will be able to message me on a daily basis when you join, or it's not possible for you. Tell me.
Ma'am, I can message, ma'am. Today only issue, ma'am.
Ah, okay. So I'm having the other class as well, no? So I'm not able to send it. Right? On a daily basis, you will be able to do that message to me
Yes, ma'am, I will message, ma'am. Only
once you
today,
join the class. Huh?
only today my mobile went outside, ma'am. That's why.
Okay. 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 No, no, no. I totally understand that, but it's like I think that if you find any problem with that, no, so we can find any other alternative, no?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. Okay. So also, what about the doubt classes? You want to take it or not? Because I have to utilize my time otherwise to another people.
Ma'am, on every Sunday can we take doubt classes, ma'am?
On every Sunday.
Yes, ma'am. Or 2 days alternatively like that.
Okay. On alternative days.
Yes, ma'am.
Okay. No issues. We can schedule that.
Yes, ma'am. Okay, ma'am.
Just update me and I'll let you know that whether on 11 o'clock I will take your doubt classes on a alternative days.
Yes, ma'am. Okay, ma'am.
Okay.
Yes, ma'am. Okay, ma'am.
Okay then. How many classes you need to schedule? Also let me know that as well.
Ma'am, yesterday I shared for 2,500, ma'am, not for 20. Uh, and today or tomorrow I will share for another 10 classes, ma'am. Total 30 will be shared.
Okay. No issues. It's like 300 for per class. Okay.
Yes, ma'am.
Okay.
Thank you.
Okay then, French, welcome.